Good morning everyone. I am Denver John Cantor, first year computer engineering student. So today I will talk about definite integration. But first, what is the difference of definite integration and indefinite integration? Indefinite integration is obtaining the antiderivative of a function, while the definite integration is obtaining the definite integral of a function. So, when we are talking about definite integration, we are talking about its formula. So, what is the formula of definite integration? This is the formula of definite integration. The integral of f of x dx is equal to f of b minus f of a from a to b. This is the formula of definite integration, where f of b is the integral of f of x at b, and f of a is the integral of f of x at a. So when we are solving equations and functions from definite integral, we will gonna use this formula, because when we won't use that, we can solve definite integration. So what is the use of definite integration? The use of definite integration is simply like solving the area of the curve on a plane. We will solve the area of the curve on a plane from A to B. So we will solve this area of a curve, the exact amount, precise and correct amount of its area. That is the use of definite integration. We will use this formula to solve the area of a plane. That is the simplest way to explain on what is the use of definite integration. Since we are done with the concept of definite integration earlier, I will now solve one of our example. So here is our example. The integral of 5x minus 4 squared from the limits of 2 to 3. So in this example, we will use u substitution. But first, how are we gonna use u substitution? We let u is equal to this expression of a function so that we can use that later on. 5x minus 4, and we let du is equal to this 5 dx. So how can we find the value of dx? We can find it by simply divide by 5 both sides, so that we can cancel the 5 here, and dx will remain. So the value of dx will be du over 5. So now that we are successfully substitute the u, we will now solve it properly. So to start, is equals to integral. Since we substitute this expression into u, we will use u squared, and the value of dx is du over 5. du over 5. We can simplify this expression by becoming it the integral of u squared over 5 du from the limit of 2 to 3. Now that we get it the simpler version of our expression, we will now integrate it. So the rule of our integration is you let the exponent n plus 1, and the denominator will be n plus 1. So what is the value of our exponent? Will be the value of our denominator later when we integrate it both. So integrate this, u 2 plus 1 is equals to 3. So our new exponent, our integrated exponent, is cube over, since we have 5 here and Our new integrated exponent is 3. We will multiply 5 by 3. So that will be 15 over 15. Put up a bracket from the limit 2 to 3. Now this is our integrated expression. Now we will transform it and substitute the value of q so that we can solve it later properly. Is equals to, what is the value of u? 5x minus 4. 5x minus 4. Our integrated exponent is cube over 15. Put up a bracket from the limit 2 to 3. This is what expression that we will gonna use later when we are solving definite integration. But first, what is the formula again of definite integration? The formula of definite integration to solve it properly is f of b minus f of a. So let us be minded that the lower limit is f of a and the upper limit is f of b. So meaning, when we solve it with our formula, it will be like this. We will proceed on solving it. 5. The value of x, which is we will gonna use is the upper limit or the f of b is 3 minus 4 cube over 15 minus the f of a. The value of f of a is 2. So 5, 2 minus 4 cube over 15. This is the f of a. This is the f of b, I mean. And this is the f of a. So now we will solve it. So 5 times 3 minus 4 raised to the third power is equals to 1,331. 1,331. Copy the denominator. 15. We will solve the f of a now. 5 times 2 minus 4 raised to the third power. 216. 216. Copy the denominator. 15. So now, 1,331 minus 1,331 over 15 minus 216 is, when you are solving fractions with the same denominator, you will only subtract the numerator and copy the denominator. So 1,331 minus 216 is equal to 1,115. Copy the denominator, is equal to 15. So now, the answer of the integral of 5x minus 4 raised to the second power from the limit of 2 to 3 is 1,115 over 15. With the use of our formula, we get this answer. For our second example, integral of 2x x squared plus 4 raised to the second power from the limit 0 to 2. We will use u substitution again, but later we will change its limits. So, we will use u substitution, so we let u is equals to this. So we can substitute it later, or we will gonna use it later. X squared plus 4. So the value of our du now will be this and this. 2x dx. So that we can cancel out 2x later. So the value of our dx will be du over 2x. I explained it earlier, so I hope you know how to solve the value of dx. So proceed to solving. Is equals to integral. Copy the 2x. And we substitute the x squared plus 4 to u. So we'll use u. Copy the exponent. And the value of dx is du over 2x. From the limit of 0 to 2. But, as we can all see, there are two 2x. So, we will cancel it out. Cancel it. So, it will be integral from 0 to 2. Cancel it out. We can also rewrite this as integral. We will take down the bracket. We can take down that du. But since we cancel out the x and we let the du and u on our expression, we will now change its limits. We can't use the limits of x because we don't have x anymore. So what we will gonna do is change its limits to its corresponding values using the limits that we have earlier. So we will use this to get our new limits. We let u. So u, always remember that these 2 and 0 are our limits, whereas the 2 here is our upper limit or the f of b, and the 0 here is our f of a or the lower limit. So we will use the 0 first since it's our lower limit. So x, we'll substitute it into the lower limit, which is 0 squared plus 4 is equal 0 raised to 2, or 0 times 0. Any number multiplied by 0 is equal to 0. So 0 plus 4 is equals to 4. That will be our new lower limit. And now it's the upper limit. So let's substitute the value of our upper limit, which is 2 raised to 2 plus 4. So 2 times 2 is 4 plus 4, 8. 8 will be our new upper limit. So we will use that here. 4 as our lower limit and 8 as our upper limit. So we have this now, and we will now integrate it so that we can solve later. So proceed to integration. It's equals to integral. So we can take the integral u 2 plus 1 is equals to 3. So cube over, since we don't have denominator and one of our rule is n plus 1, so we will just copy the integrated exponent and become our denominator. Cube. We can take down du also, since we are integrating. We don't need to put du anymore. Put up a bracket from the limits 4 to 8. So from the limits 4 to 8. This is the expression, the integrated expression that we will use to solve the definite integration of this expression. So proceed to solving using the formula f of b minus f of a. So the value of our f of b is 8 and the value of our f of a is 4. So u, since the value of our u now is our new limits, we will substitute our u into our limits. So first, the value of f of b, or our upper limit is 8. cube over 3 minus the value of our lower limit, which is 4. 4 cube over 3. Now we will solve it. 8 raised to 3. 8 raised to 3, or 8 times 8 times 8 is equals to 512. 512. And we will copy the denominator. Minus 4 raised to 3. 64. 64. Bring down the denominator 3. Since I tackled you earlier that when you are subtracting fraction with the same denominator, you will just subtract the numerator and copy the denominator. So 512 minus 64 is equals to 448. Copy the denominator 3. This is our answer. So the answer of the integral 2x squared plus 4 raised to the second power from the limit of 0 to 2 using the u substitution and the changing of limits is equal to 448 over 3. Always remember that when we are solving definite integration, we are finding the exact amount, the precise and correct amount of the area of a curve. So, imagine when we are plotting this now and we are solving the curve of a plane, this is the value of our curve. This is the value area of our curve. It is the exact amount. We don't use plus c. That plus c is the constant that we are using in indefinite. But in definite integration, we doesn't use plus c because we find the exact amount. And always remember that the true essence of mathematics is not to make simple things complicated, but to make complicated things simple. That's all, and thank you.